Hi class. We have two more graphs that we want to create here of these quadratics that make this parabola shape. Now we started this one in class and it's okay. It did have a slightly weird thing. The asymptote, if you remember, was let me use this color. The asymptote for the vertex was negative b over 2a. And that's a negative of negative 3 over 2 times a, which is 1. And we got a axis of symmetry. Oops, I said vertex. It's just the axis of symmetry. And it was positive 3 over 2. And we could have done that problem. It's just the axis of symmetry would have cut right in here. 3 over 2 is 1.5, so it's kind of in the middle. And we worked on getting the vertex point, and it's way down at the bottom here. And it was off the scale a little bit. That's all manageable. But because it's off scale, I'm going to make it just a little easier for us. And so I want you to update the problem. Okay, so scratch off the original problem there. And I just dropped the numbers a little bit. The negative 3 I made to negative 2, and the negative 10 I made to negative 8. And it still gives us some of those interesting details, but it'll just be a little smoother and quicker since I'm on a recording. I don't want the problem to take a whole long time for you guys with the recording. So it's always a good idea to at least mentally or even physically write them down. What are the coefficients? A is the coefficient multiplier of x, which is 1. B is negative 2, and C is negative 8. Now, we learned a few things in class. The y-intercept, when you're on the y-axis, x always equals 0. And your point is always 0, C. Hey, that's easy because we have the C number, 0, negative 8. So the parabola is crossing, and it's crossing way down off our grid. 1, 2, 3, 4. Here's negative 5. Negative 6, negative 7, negative 8. So there's my first point plotted. Okay, now number 2. I skipped those in class today, but since I got a little bit more time, I'm going to slow down just a little bit here because we know how to get the x-intercepts. They're just a little bit involved. But x-intercepts always happen when y equals 0. So that's going to be a point, question mark, comma, 0. And it's also taking 0 and plugging in 0 right here for y. Now, it turns out we know how to solve that. We can solve that by solving the equation just like we did in 8.6. Okay, since y equals 0, I can play around with the yellow equation. Notice this part that's highlighted as yellow. I'm going to take the y out and plug in 0 into that equation. So I don't have y anymore. I plugged in 0, y equals 0, and I don't know the x's, x squared minus 2x minus 8. So I'd like to find those x's when y equals 0, and we know how to do that. That's an 8.6 kind of problem. In 8.6, what we did when we had second power is we broke down the second power by factoring it. And this one has 3 terms, so it would be reverse FOIL. And numbers that multiply to 8 are 1 times 8 and 2 and 4. I think it's going to be 2 and 4. And we need to check the signs, play around with the signs, but we're going to have to go plus, minus. Positive 2 times negative 4 makes the negative 8. And then a negative 4x plus a positive 2x makes negative 2x in the middle. And if I solve these two, I have x plus 2 equals 0. And I have x minus 4 equals 0. And I'm a little bit tight on space here, but if I minus the 2 and I add the 4, I'm going to get two x answers. X equals negative 2 and x equals positive 4. So what are my y-intercepts? My y-intercepts, I have 2 of them. So this time the parabola is going to cross the y-axis in 2 places. X equals 2, so I've got 2, the y number is 0. And I'm going to do the 0 in color coding like I did before. The y was 0. And I've got another one, x equals 4, and the y number is 0. So we actually know how to get those x-intercept points, and we do them by solving the equation. You factor it. And I want to plot those 2 points. So 2, 0 is right over here. My bad. I left off the negative. Bad form there. That's a negative right there. Don't lose the negative. See, it was a negative 2. And so I've got to plot the negative 2 right here. And then 4, 0, 1, 2, 3, 4, 0 is right there. So I actually have 3 points. And all I've got is the intercept points, the 2 x-intercepts and the 1 y-intercept point. Now let's keep going with our analysis. We have this little formula for the axis of symmetry. It is, I'm going to do it in red because I like to do the axis of symmetry in a different color. The axis of symmetry is an x equals equation of negative b over 2a. So x in this problem will equal negative of b, and b is a negative 2. Divide that by 2 times a, 1. And this equals 2 over 2, which equals 1. So our axis of symmetry is x equals 1. All right, so I'm going to come to x equals 1 and draw a dashed line. This is my dashed line. This is the mirror. The parabola is going to be reflected on both sides of that mirror, including this point down here. Notice I have a mirror image 1 space away on the other side. Now another thing to notice, look at the 2 x-intercepts. There's 3 spaces forward, 1, 2, 3 spaces back. So the x-intercept points are also doing the mirror thing. I'm going to erase that though. So I'm pretty close to having a really nice graph. I just need one more thing, and that's the vertex. Now recall, the vertex is an xy pair. xv, yv. That's the xy pair for the vertex. And we have a formula. xv equals negative b over 2a. Okay, now remember the red part. The red part is the red line. The xv is not a line. We're talking about a specific point, and the point has an x number. But the formulas are the same. So the x number of the vertex is also the same as the x equation for the axis of symmetry. So I'm already halfway done. I know that that number is not 2. 2 over 2 is 1. Okay, now how do we get the y number? Well, we're just going to take 1 and plug it in. Plug in 1. So we have this y equation. Y equals, I'm taking the x's out. And then in each one of these, I'm going to take x out and replace it with 1. And then just do the math. So that gives me 1 squared, which is 1 minus 2 minus 8. 1 minus 2 is negative 1 minus 8 equals negative 9. So I have the vertex point. It is down here at negative 9. Special point, I'll keep that in green. So this was negative 5, negative 6, negative 7. This is negative 8. And one more down here makes negative 9. And the vertex point is over 1 down negative 9. There it is. That's the turning point. That's the vertex. Now I have 5 points. That's a pretty good effect to graph, and I can make a quick sketch of this one. Now, because we were able to produce so much with the first 4, we don't really need too much about A. The A number, A, oops, wrong. Let's go back to green. A equals 1, which is positive. So the parabola is going up. We know that already. And also A is a 1 coefficient. That's the normal. It's not wide. It's not narrow. It's the normal dimensions on the parabola. So we're not getting too much on number 5 here, but we can sketch this graph and got it. Connecting the dots. And you can tell my sketch isn't perfect, but it's a pretty good sketch because of the analysis that we did with those 5 things we analyzed. All right, one more. Let's practice this analysis one more time. Okay, definitely a little bit of a harder problem. Let's take a look at it. Okay, here we go on this next one. Now, it's a harder one. I think I took it from Mom just so you could see an example of one more difficult kind of problem. So let's get started with what we know. Okay, A equals -3, B equals 23, and C equals 8. Okay, now I'm skipping down to the bottom. A equals -3. What does that tell us? Well, because it's negative, this parabola has to be pointing down. Also, the 3 it's not a fraction. It's not like 0.3 or 1/3. It's a whole number. It's bigger than 1. And because 3 is bigger than 1, it's going to be a little bit narrow. So it'll be skinnier than the last parabola we saw. So we've got 2 clues right off the bat there. Now we have another easy clue. Let's go back to the top, the y-intercept point. Now remember, if you're on the y-axis, what is x? If you're on the y-axis, that means x equals 0. So you're going to have 0, c, and in this problem, that's going to be 0, 8. Okay, let's hold on to that thought. And now let's find our y-intercepts. Now remember, I said that backwards. When we're on the y-axis, the y-intercepts, our x number is 0. Now we're going to go to number 2. When we're on the x-axis, our x-intercept points, that means y equals 0, and we're looking for an x question mark, comma, 0. Now sometimes it crosses the x-axis twice. Sometimes it crosses it once, and sometimes it crosses it not at all. But remember that the 0 is my x number, and I'm going to plug it in for y. And when I plug it in, I get an equation that I can solve. Okay, so I'm going to take that off and do that. So we got 0 equals -3x squared plus 23x plus 8. Now, you may need some scratch paper to start doing the trials and errors and guessing and checking. There's a lot of difficulties with this one. The leader is negative, and that makes the guesses harder. So here's the trick. There's no common factors, though. 3, 23, and 8 have nothing in common. But the negative is making things difficult. So I'm going to factor -1 out. And that way I have 3x squared minus 23x minus 8. And because the leader now is positive, it's going to make the guesses a little easier. Now, I'm not going to go through the whole guess and check. I'm just going to tell you what the answer is, and we'll write it down. But in your paper, you're doing your work, you'd probably have to take your time with that and do the guessing and checking, and it would probably take you a couple minutes. But we're not going to do the couple minutes here. We're just going to get the answer. So you can see I just popped in the answer there. Let's check that really quick. The 3x times x, that's 3x squared. Check. Then there's the last term, 1 times -8. That's the last term. So we've got the first term and the last term. We still have to check the outer and the inner. And so let's do that. And if that checks, we know we're good. So 3x times negative 8 is negative 24x. The inner is positive 1x, which is negative 23x. That checks as well, which means we've got the answer factored. Now, we haven't solved it yet, but we have factored it. And so I'm going to erase here. Okay, now remember this thing equals 0. I ran myself out of room here, but the negative 1, 3x plus 1, and the x minus 8 equals 0. Now the negative 1 is a multiplier of negative 1. Negative 1 is always negative 1. It won't contribute to the solution. But 3x plus 1 could equal 0, and x minus 8 could equal 0. So we can solve the easy one at 8. And so we get our first x answer. X equals positive 8. Now that means then when x is 8, y is 0, I have a point. Okay, so we don't have much room. I'm sorry. You have a little bit more room on the side of your notes than I do. But I'm going to erase it and solve the other one now. Now it's 3x plus 1, so I have to minus 1 on both sides. Now I got 3x equals minus 1. Now I have to divide by 3. That's a special x. How did we get this x? This x we got when y equals 0. So when y equals 0, we got another x. So that means we can come over here and say, oh, we've got another point. That point is negative 1/3, 0. These are the 2 points where I land on the y-axis. That's interesting that the intercept has y equals 8 and the x-intercept has an x equals 8. And so, but that's what we're looking at here. And maybe we should plot the sum of these points that we've figured out here. We've got 3 of them. Now the y-intercept, we cross the y-axis at 8. Now notice the scaling of this thing is scaled very differently. The y-axis goes all the way up to 60. And this first mark here is at 10. So we're going to have to count by 2s. 2, 4, 6, 8. No, we're going to have to count by 2.5s. Oh, that's awkward. 0, 2, 4, yep. This is halfway, which is 5. And this is 7.5. So when we plot our 8, we're not going to have a perfect plot. But it's just a little bit above the 7.5. So we have 2.5, 5, 7.5, and then 10. So the scaling, we have to really deal with some different kind of scaling here because we're going to have a tall parabola. And let's see, then there's on the x-axis. Okay, x is doing a lot better. X is counting by 2s. Well, actually, the big grids are 2, 4, but the minor grids are 1, 2, 3. So halfway is 1. So this is 1/2. So the scale on the x-axis is counting by 1/2. But that's a little bit more obvious than the y-axis, especially because we can see 8 right over here. We got 8. Now, we do have one more intercept point. It is this one here. It says negative 1/3. Where is negative 1/3? Well, it's smaller than a half. Now, as we said before, halfway to negative 2 is negative 1, and halfway between 0 and negative 1 is negative 1/2. Now, 1/3 is a little smaller than that. Now, it's not perfect, but I'm just getting close. That 1/3 is going to be around here because it's a little smaller than 0.5. Okay, but that's my x-intercept, my y-intercept, and my other x-intercept. Okay, so we got a little bit more to do, I think, to figure out this graph, because those points aren't too descriptive yet. But we got the axis of symmetry. So axis of symmetry is negative b over 2a, and b is 23. So we're going to go negative 23 over 2 times a. 2 times a is 2 times negative 3. And this equals negative 6 and negative 23. So the negative 23 on top and the negative 6 on the bottom, it does not reduce to at all. The axis of symmetry is 23 over 6. Now that's a little bit awkward of a fraction. I'm trying to clean up the equal signs in there. Man, my eraser's not working for me too well. I want to erase the equals and it won't erase everything else but the equals. Okay, x equals 23 over 6. Now, I don't know. Well, that's hard to graph. 24 divided by 6 is 4. So this is really close to 4. I'm going to put that in my calculator. And if we do a calculator thing and do 23 divided by 4, we're going to get a decimal. And so we could also say the axis of symmetry is 5.75. Nope. Typo. My bad. 23 divided by 6 is not 5. It's 3.83 repeating. 3.83. Okay, so that's pretty close to 4. Not perfectly at 4, but really close. So I'm going to come over to 4 and just do a little bit to the left of 4 on the x-axis, because where it crosses down here is x equals 3.8. It's not perfect, but it's going to be good enough for us to sketch. And that's helpful because I have symmetry. Here I've got symmetry. And it's 1, 2, 3, 4, 5, 6, 7, plus a little bit more. 7 plus a little bit more of the small boxes. And so if I have this little bit more here, plus 1, 2, 3, 4, 5, 6, 7 boxes, I get this symmetry point on the other side. Now that's encouraging because I'm starting to see some prospects of a parabola. Okay, one more thing. We need to find the vertex. Now, we've already found the vertex part where it's x, v, y, b, because the x-coordinate for the vertex is the same as the axis of symmetry x number. Okay, so this is definitely going to take some calculator work, though. The vertex point, 3.83, that's the x part. Now I have to find the y part. Question mark. How do we get the y point? We plug in. So what we're going to do, I'm going to work down here on the bottom, is we're going to take y equation minus 3 x squared plus 23 times x plus 8. Now I'm going to take the x out and I'm going to plug in 3.8. Now I've rounded it off a lot, but it's pretty close. So we won't get the exact vertex, but we're going to be close enough. And this is where we're going to use our calculator. So in order to get this thing, the 3.8 is not mental math. We're going to need to do that in the calculator. And so you try it in your calculator along with me. I'm going to take 3.8 to the second power and then times it by negative 3. So you should be getting negative 43.32 plus, now we've got to take 23 times 3.8. 23 times 3.8, you should be getting 87.4. And then lastly, we've got the plus 8. And when we take the, add up all those numbers, you got one more thing to do to add up. You should get 52.08. And I'm just going to say that's 52. So with the 52, let's plug in our points here. And so we've got 3.8, comma 52. That is our vertex point. Now 52 is quite large. It's way up there. Okay, so where is that? That's 3.8 right around here. And then we need to go up on the y-axis. Here's 40, and here's 60. Nope, my glasses need to be better. Those numbers are really small. There's 50 right there. Now these are counting by 50, and they're counting by 2.5s. So 52 is just about there. And it's not perfect, but it's pretty good. And so we've got all the analysis done, and we're able to sketch a graph here of an extremely hard parabola. This was about as hard as they get. Most of your problems won't be this hard, but I wanted you to see one hard one. And there you go. So practice this. Mom will give you practice tonight, and hopefully these 5 points will make it easier for you when you're graphing them. Study hard, and I'll see you guys on Wednesday. Bye-bye, everybody.